Welcome to this tutorial on the MD5 command. MD5 is a powerful tool used to generate MD5 hashes from strings and files. These hash values are commonly used for checksums and unique identification purposes. Throughout this tutorial, we'll explore how to use MD5 for various practical applications, including file integrity verification and data validation. MD5 stands for Message Digest 5 and is a cryptographic hash function. It produces a 128-bit hash value, which is typically displayed as a 32-character hexadecimal number. MD5 has several key characteristics. It always produces a fixed 128-bit output regardless of input size. It's a one-way function, meaning you cannot reverse the hash to get the original data. It performs fast computation, making it efficient for large files. And it produces deterministic results where the same input always generates the same hash. The basic syntax for the MD5 command varies slightly depending on your operating system. On most Unix-based systems, you'll use the MD5 command followed by options and the file name. On Linux systems, the command is typically MD5 sum. Common options include -s for hashing a string directly, -c for checking hash values against a file, -q for quiet mode, which suppresses verbose output, and -r for reverse format output. To generate an MD5 hash from a text string, you can use the MD5 command with the -s option followed by your string in quotes. For example, MD5-s quote hello world quote will generate the hash. Alternatively, you can pipe text to the MD5 command using echo. The result is always a 32-character hexadecimal string. In our example, the string hello world produces the hash 5D41402ABC4B2 a 76B9719D911017C592. MD5 can generate hashes for files of any size. Simply provide the file name as an argument to the MD5 command. You can hash a single file like document.txt, specify a full path like /path/to/file.dat, or use wildcards to hash multiple files such as *.txt for all text files. File hashing is commonly used for file integrity verification to ensure files haven't been corrupted, detecting file changes over time, identifying duplicate files in your system, and performing data corruption checks. MD5 can verify file integrity by comparing current hash values with previously stored ones. The MD5 sum command with the -c option reads hash values from a checksum file and verifies them against the current files. You can also pipe a hash and file name to MD5 sum for individual verification. The verification process returns specific results. Files that match their expected hash show OK status, while files that don't match display failed status. This verification process is essential for ensuring data integrity and detecting any unauthorized modifications. You can generate MD5 hashes programmatically using Python's built-in hashlib library. First, import hashlib, then create your text string. Create an MD5 hash object using hashlib.md5 and pass your encoded text. Use the hexdigest method to get the final hash as a hexadecimal string. The Python implementation produces the same result as the command line tool. For the string hello world, both methods return the identical hash 5D41402ABC4B2 a 76B9719D911017C592. While MD5 is useful for checksums, it has important security limitations. MD5 is vulnerable to collision attacks where different inputs can produce the same hash. It's no longer considered cryptographically secure for security-critical applications and has been officially deprecated for such uses. The fast computation that makes MD5 efficient also makes it easier for attackers to perform brute force attacks. For better security, consider using SHA-256 for general security purposes, SHA-3 for modern applications, or Blake2 for high-performance needs. Reserve MD5 use primarily for non-security critical checksums and file verification where collision resistance isn't paramount. If you like this video, Hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.